Car insurance companies, every year, deal with many insurance claims, both true and false. Wouldn't it be nice to predict it with high accuracy? That is why with CarClaimPro, you can have smarter predictions and smoother rides.
There we go. So just a quick little introduction, made using Runway ML, so AI generated videos, just to give a brief introduction on what our product is all about. So without any further ado, I'll pass it over to Jeremy, who will give a little bit more background information on our project, our data set, and kind of our goals for it.
Car insurance companies provide financial protection against car damage or physical harm resulting from traffic collisions and against liability that could also arise from incidents in a vehicle. This model predicts the probability of a policyholder filing to claim such car insurance. The goals of this project are to create an accurate machine learning model from scratch, develop relevant industry skills needed in data science, experience team product development, and enjoy the process. Before we started this project, we made some hypotheses of what factors could lead to more car insurance claims. For example, we predicted that younger drivers cause more collisions, more safety features on a car would lead to less collisions, and the chance of a claim increases when the policy tenure is older.
That's good. And then just in case you guys aren't familiar, this policy tenure, that basically just means how long a person has car insurance. So if you bought your car insurance in the 90s, you will have had car insurance for 20 years, so your policy tenure is 20 years old. And then moving on to a little bit more EDA, exploratory data analysis, just to show you guys some data that kind of supports our hypotheses or just kind of shows some new interesting data on it.
This is our correlation heat map. It pretty much just shows the correlation between all the different variables in our data set. Our target variable is claim, which is kind of in the middle. As you can see, it does have a relatively low correlation with pretty much all the variables. So our models actually just train on the difference of the correlation instead of the correlation itself between the variables.
Another data visualization that we use is the bar graph. So this bar graph, we're trying to display the correlation between the car insurance claims and policy tenure. So to do that, we calculated the average of policy tenure when car insurance is claimed and when car insurance isn't claimed. So, and then we displayed that on the graph. And from this, you can see that the average policy tenure is actually higher when car insurance is claimed. So, which is something kind of interesting. And well, it is probable that this is because when you have the car insurance for a longer time, then there's an increased chance of accidents happening.
Yeah, just kind of the longer you have your insurance, the more time you have to get into a car accident.
And we also created a correlation matrix to show the correlation between speed alert and claimed car insurance. And we used the data that we got from this correlation matrix to also calculate the percentage of claimed car insurance based on with or without speed alert. And we found that with speed alert, you have a 6.4% of cars file for a car insurance claim, while 4.1% of cars without a speed alert filed for a car insurance claim. So the percentages are kind of similar. And in fact, those with speed alerts actually have a higher chance of claiming car insurance. So that kind of undermines our hypothesis that safety features would decrease the chance of application for a car insurance claim.
Yeah, thanks, Joanna. And then here's just another example of a visualization that we did, just kind of showing the correlation between two of our variables. So here I'm just comparing the age of the policyholder and the age of the car. I was kind of expecting to see maybe an inverse correlation or a positive correlation showing that maybe older people had more money and so they had newer cars, something like that. Turns out there's not too much of a correlation, and that everybody for the most part wants and has a newer car, which is good for car insurance claims because those also tend to be safer. Then moving on to some histograms.
And for our histogram, the first one we made was one that shows the demographic of the policyholders that applied to claim a car insurance. So like the age of those car insurance holders that asked the car insurance company for money. And we found that like the age demographic is more concentrated in younger policyholders, around 0.3 to 0.5. So that means that younger policyholders have a higher chance of claiming car insurance. And our second histogram shows the correlation between the age of policyholder and all policyholders who bought a car insurance, no matter they claimed it or not. And this also shows that like they're also more centered around the younger demographic. That means that the younger generation are more likely to buy car insurance.
Okay, and then these are just some pie graphs of the distribution of our data. And so as you can see, there are some categories where our data was not very spread out, such as power steering and speed alert and parking sensors, where it was mostly dominated by cars that do have those features, while there are others that were more spread out, such as parking cameras and adjustable steering and the type of transmission. And so we found this interesting since that might impact our data analysis, our machine learning model.
Speaking of those machine learning models, we'll talk a little bit about those and ones that we used.
Okay, so me and Blake will be explaining these machine learning models. We use classification models since we're only trying to figure out or trying to predict if a car had an insurance claim or didn't have an insurance claim. And one of the first models we used is KNN, which stands for K nearest neighbors. And it basically works by looking at existing input data, and it predicts new data based on that existing data. So as you can see on this confusion matrix that we made, our KNN model predicted a lot of, or correctly predicted a lot of cars having no insurance claim. But as we can see on the right side of the confusion matrix, it made no attempt to predict if a car actually had an insurance claim. So this model would not be very useful for us since that's kind of the whole point of our product. And then the next model we use is the Gaussian naive Bayes model. And it's just another classification model that uses different parameters and inputs to create like one prediction for our target variable, which is our insurance claim. And as we can see on this confusion matrix, it's pretty similar to the KNN model. It has a lot of correctly predicted true negatives, as in the car has no insurance claim. But once again, it did not attempt to make any predictions if the car did have an insurance claim. And another model we used is the random forest model. Basically, the random forest takes multiple decision trees, which in turn, they function by using previous data to ask like questions about new data and make decisions on them. And it basically takes multiple decision trees and creates a large prediction based off of it. So as we can see on this confusion matrix, it's slightly different than our previous two models. It had around the same amount of true negatives, meaning it had predicted cars not having car insurance about the same like accuracy. But this time, this model actually tried to predict if a car had a car insurance claim, which is better than the other two models. But the problem with this model is it had a very low accuracy. It only predicted 20 models or cars correctly. And passing on to Blake.
Okay, so our next model is the XGBoost model. So the XGBoost model functions by using gradient boosting, which combines simpler, less advanced models and creates a prediction-based return upon the combination of these models. So here we can see a visual. It goes from the data to the subset to the tree. And when we plug in our data into it, we get a confusion matrix like this. So the XGBoost model correctly predicted 13,000 cars that did not have claims, 128 cars that had insurance claims, and it incorrectly predicted 809 cars that do not have insurance claims. Unfortunately, it had 0 incorrect predictions for cars having insurance claims. So this meant that the model had a skewed prediction, meaning we cannot use it because of that. Our
Basically,
final,
just not enough weight on the true positives there.
yeah. Our final model is the decision tree model. So the decision tree model, which is the basis for the random tree forest and the XGBoost model, works by using previous data and outputs it in order to create a question to ask a new data set. So here we can see our decision tree, and this is the actual decision tree we use by inputting our data. So next, here is the decision tree confusion matrix. This is the original one. So here, it correctly predicted 10,000 cars having no insurance. It predicted 59 and also predicted 59 cars with claims correctly. However, this model was not that accurate, as the F1 score was 0.072, and we were fortunately able to devise a way to improve our model by changing the class weights and values for our decision tree. This significantly changed our model accuracy, as shown below, where we have 11,000 cars predicted having no insurance claim, 702 cars having an insurance claim. And while the accuracy was not that good, it was the best out of all of our models. And as you can see, it has a much higher F1 score than our previous model of 0.185.
So just kind of showing a little bit more of an accurate ratio between correct predictions or positive predictions and negative predictions.
So in conclusion, most of our findings support our hypotheses. So on average, younger drivers do tend to get into more collisions than older drivers, so they submit more insurance claims. And also longer policy tenure leads to a higher chance of a claim, which makes sense since there's more time for the drivers to get into accidents. However, even though we thought that the cars with more safety features would get into less accidents, that wasn't really the case, so that disproved our hypothesis. But overall, our model was able to take into account all the factors that we discovered and make reasonably accurate predictions on whether there would be a claim. So we count that as a win. We enjoyed working on this project and learning more about machine learning and AI.
Yeah, so that's our project. Here's our little our team page, giving a little bit of info about each of us. And then maybe what I want to do next is just show you guys a brief little demo of our product. So right up here, if we click our product page, we'll open a new tab, and we can see this HTML form where we can input a bunch of different factors about our car or about our car insurance policy. So we restricted these ranges to the ranges that were used in our data set. Some things make a little bit less sense. So for example, the normalized age of the policyholder, we can only input in the range 0 to 1. So that's just normalized, basically dividing the average lifespan of a policyholder by the average policyholder. So just kind of showing age as a percentage rather than in years. So we have a lot of different variables like that. So basically converting a lot of our variables to numerical data so they can be used in our machine learning model. So I'll just go through each of these and do the minimum for each. And I'll show you guys the prediction. And then I'll actually also show you guys how we can input some real values to get a better prediction. So go ahead and click predict here. And we get prediction: the car owner will not file for a car insurance claim based on the factors that I input. So there's that. And then here, I just went ahead and prepared some data for a car insurance policy that is expected to result in a claim. And if we go ahead and click predict on that, oops. Maybe I didn't do enough preparing. It's okay. we'll see what this one does. Never mind. Okay, technical difficulties. We do not have another one to share. But you can see that based on a few different input factors, we can make predictions on whether or not there will be a claim, which we were able to confirm in a few different scenarios. So that's our project. I hope you guys enjoyed seeing it. And yeah, we're open to any questions that you